We're going to do another TMiP Animation Generation Collaboration. I'm sure that would be quicker if I said the acronym, so TMiP AGC. Maybe that's unhelpful. Every month, the Talking Maths in Public community has been having a challenge to do a mathematical animation and record a video of how we make that animation. I hope you recognise on this channel that's what I enjoy doing. This month's challenge is a lovely one, as they've all been, despite me missing last month, sorry. This is a curve of pursuit challenge. Can we create an animation which shows a curve of pursuit, which is the idea that when you have some points chasing other points, which are also chasing other points, what shape do they end up making? This is much easier to try out than it is to imagine as a thought experiment, which is what's great about having software like GeoGebra or Desmos to do this sort of thing. The animations you get are really lovely. Let's not give too much of a spoiler. Maybe you know what they're going to look like, maybe you don't. Let's make it from scratch and see how they turn out. I'm going to do it in two different ways because I think the two ways are very distinct. I'm going to do them and they have different advantages and disadvantages. This is really a showcase of two ways of animating something stepwise in GeoGebra, both of which I use regularly. And I'm not sure which I'd have to claim as a preference. Maybe I'll decide by the end of the video. First up, let's use it using a time slider and a scripting command. Okay, I'm going to start this example with a triangle. I've got a GeoGebra 5, Classic 5 window here. I'm using the polygon tool to draw a triangle. You could do any shape you like. I'm going to turn off a few things. I'm going to turn off the labeling because I don't want labels to be polluting things. I probably don't even want these labels visible, so let's hide them. I will turn off the axes because I don't really need them. And the grid, why not? Let's keep it pure. I might not even want that triangle, but let's leave it on for now. And we will try to make point A chase point B, and point B chase point C, and point C chase point A. The catch is, I'd like those original points to still be there and make some other points move. So I'm actually going to have to leave A, B, and C alone and create some new points which start at those points. So I'm going to start that process just by making 3 new points. Now I've turned my labeling off, but I can see the D, E, and F. If I'd left labeling on, maybe that would have been easier to see. The point is, these are completely free at the moment. They're nothing to do with A, B, and C. So let's establish some way of getting them to the right position. And this is the beginning of what I'm going to call the scripting method of things. The button command in GeoGebra, there's a button in this drop-down menu, basically gives you a button to press and it does some GeoGebra commands. Now, there are lots of commands that you might have used in the title bar that are sort of code for some of the buttons you're used to using in GeoGebra, but there's always a command, and there's quite a lot of commands that are never part of the buttons at the top there either. I'm going to call this a reset button, and one very, very important scripting command, there's no button for this because it's to do with when it's going to run a script in the background, is to change the value of something, and the command is set value. In lots of programming languages you might just say variable name equals something else and it kind of updates the value of that thing. Now you can get away with that in GeoGebra, but it quite often creates new objects. If you say D equals something, if there isn't an object called D, then make that object. And actually I don't want it to make new objects. I don't think it would if there's already an object called D, but I'm going to use the set value command, and I think it's a better habit for scripting in GeoGebra to change the value of another thing by using the set value command. It takes 2 arguments. The original one is the value of the name of the variable you want to update, and the next argument is the value you want to update to. So I'm going to set the value of D, which is one of those new points I made at a random position, to be A. And it's so basic that it's kind of hard to read that, parse it, but it's going to take the value of D, whatever it is, and make it the same as the point A. And let's do the same for the other points. So this is just going to reset those 3 points back to wherever A, B, and C are, the original points I made. Hopefully I did them in some sort of sensible order. It doesn't really matter. I think that is going to create a button. There it is. And if I click it, those 3 points are going to overlap onto A, B, and C. And they do. I clicked it with the button tool, so it's trying to make me a new button as well. I don't want to do that. Go back to the arrow and it does reset it. I can't see anything happening. If I drag this point, you can see I wasn't dragging A. I can drag A, but I'm dragging point D now, and if I reset it, it puts it back over there. So far so good. Now I realise I want D, E, and F to be the ones that move around, and I've got A, B, and C as my original points, which I could drag to change the original starting points later. So the way that the big principle here is this scripting idea, which I can make a button do. I can also make a slider have a scripting command. So I'm going to make a slider called T, which is kind of loosely for time, but you need to not think of this as time necessarily. It's just going to be a slider, which I'm going to let go from 0 to 1. It wouldn't really matter what I let that go between. And I'm going to let it go in small increments because I just want it to have lots of changes. All I'm going to do with this slider is change in its properties in the scripting option what it does when it updates, with a view to letting this animate, which means basically letting it update regularly. And every time it updates, it's going to run whatever I write in that scripting window. What do I want it to do? I want it to move point D towards point E, whichever round that's going. And I realise I need something else to tell it which way to go, because point E itself is going to be moving, so I need to be regularly updating which direction things need to go in. So before I add the scripting in here, I need a couple of other things. One is I'm going to create a slider called step. This is very common in any sort of iterative procedure, how big a step to take. And the big spoiler is if you're going to approximate some smooth curvy motion, you could probably do that with lots of tiny steps, which are straight lines. That's what I'm going to use. So I'm going to let step not go very large. In practice, I think I want this to be really small, but it might be useful to have it large so I can check it's working. So that's why I've set those parameters in there. Let's leave it there. It's not doing anything yet. And I'm going to set some vectors between my points D, E, and F. So there's a command called vector. It takes a start point and an end point. If I go from D to E, you can see it's made that line. The catch is here, the lines from D to E and then say E to F or something else, they're going to be different lengths. And I think I want these points to move at a constant speed that doesn't depend on how far away from their target. Now, different model to say move quicker if you're further away, different curve of pursuit is going to arrive, but let's keep things simple. So I'd like to standardize the length of this. So there's also a command called unit vector, which makes it length 1. And so it looks weird to stack two vector commands. I want a unit vector of the vector from D to E, and now it's made a little unit vector of length 1. Let's do the other ones. I could have named it something more helpful. Let's call it D velocity. I don't know if it's a velocity vector, it doesn't really matter, but it's the point D which way I want it to move. Let's use V for vector then, maybe that's fine. Let's say EV is going to be the unit vector of the vector from E to F, and then FV should be the unit vector. By the way, if you've got a command you've just written in, you can press up or down depending on where your input bar is to get the previous one, and then you can just tweak it if you're doing a few of them which are similar. So unit vector from F to D in that case, it's kind of going back around the cycle. Now it's showing them on the screen. That's actually quite useful to have those vectors. I might quite like to have them there. For some reason it's labeled DV and not the others. I don't know why. Those vectors I'm going to use to update the position, and I'm going to multiply how far along that vector to go by the step, which means I can control how big a step to take. So now I think I'm ready to do my update script. Again, reminder, it doesn't really matter what T is. I'm not going to use the value of T, although I could for a different thing. I'm just going to use the fact that it's going to change often and quickly, depending on how quick I let this animate. And every time it changes, it will run the onUpdate script. This is one basic way to create continuous animation in GeoGebra. And actually, it's going to be pretty simple. I want each time it calls this update script to set the value of D to be slightly different. I want it to go a tiny step along that vector towards E. So I'm going to set the value of D to be whatever it used to be, D plus step, which is the small amount, times dv. That's what I called it. And something similar for the rest. So let's just copy them and change it to E. Didn't need to delete the plus there. Change this one to F. And I think that will do everything I want. Close that. And now if I just tweak T, you can see these things are moving. Can you see that this T value doesn't matter? It's just the fact that every time it changes, it will call that script. This is why I need the reset button to get them back to where I started. But if I let this animate, it will do it nice and smoothly. And we see these things chugging quite jerkily around. But the arrows are nice to see where they're aiming. And we have just generated the points along some curve of pursuit. Several things to do to tidy this up. Find a way of maybe starting and stopping it easily. That's going to be another button to start an animation. We've got the reset button. Maybe I can reduce the step size. If I take that right down and animate this, it is moving smoothly, but not as quick as I'd like. So I'm going to have to play with the balance between maybe the increment, like how many little steps it's going to make between 0 and 1, but also the speed. So let's just multiply that by 10. T is moving much quicker, but these points are not moving much quicker. It's nice and smooth now. If I increase the step, they'll move a bit quicker. And it's just, I guess it's balancing the speed of your time slider and the step size. This is always an approximation. The other obvious thing I need to do is trace these points. So these three, I'd like to turn the trace on. If I reset that now, Control F clears a trace, by the way. We could do a button to change that, but let's animate this now. And here's a curve of pursuit with the little arrows telling us where to go. That's nice, it's super organic. Please notice if I change the original starting point, nothing about those points have changed. They're completely irrelevant compared, like they don't remember where they started, and that trace is still there. If I reset it now, they will go from back where they started, but that old trace will not clear. Control F clears the trace, reset it, and I'm getting that. So this is nice and organic. It's actually very simple, just using a slider to repeatedly call an update script. But that curve of pursuit is not going to change if I change my starting points. It was like a one-time experiment simulation done, and if I wanted a different set of starting points, I have to run the experiment again. It's already quite nice, and this is a very useful technique to get something called repeatedly. GeoGebra doesn't let you do a for loop like in coding languages unless you pop into the JavaScript scripting. Not today, sorry. So this is one way to generate a cycle, very useful in an animation situation. There is another way though. Instead of making this just call it repeatedly, we kind of do it with a GeoGebra command. We're going to iterate a GeoGebra command to move these points. And in theory, we will be able to do this so that if we change the original starting points, the curve will track with it. And that would be nice to see how they change as you drag the starting points around. Let's do part 2. Okay, we're going to try another way. Maybe let's upgrade this while we're at it to be more points. We can use more points than the triangle. Should we go 5? Let's do 5. It would be nice to maybe put these in a regular pentagon. We can change these around later on, so let's just keep them somewhat random at the moment. I want to try and build this in a way that if I made 6 points, the commands will still work, so I could maybe upgrade it later. But let's just remember that the actual shape here doesn't really matter. I don't need these labels, and I can hide the polygon. Those are going to be my starting points. But I'm going to use the iteration command. There is one in GeoGebra. In fact, there's several. I'm actually going to use the iteration list command, which shows you all the steps along the way, whereas the iteration command just shows you the final step after you've done n iterations that you put in that count thing. Now, to do it this way, slightly more fiddly involved, we're just going to have to handle lists better. And the first thing I will need is a list of the points I'm going to use to create my curve of pursuit. So this time there'll be 5 of them. Very useful list shortcut is to select the points you want and drag them into the bar up the top, and it's made a list of those points. Very useful way of creating a long list if there's things you don't want to type in. I'm going to give that list a name. Let's call it PTS for points. Those are the starting points. Now I want to generate one command which takes a list and generates a new list, which is the next step on the curve of pursuit. So basically a new list of 5 points that have all moved slightly towards their target. And again, they're going to sort of wiggle target A to B, B to C, D to C, and so on around. Slightly irritating because I've got a list of points and I could just say make a list of vectors that go from one point in the list to the next point in the list, but then the last one's got to wrap around. That's going to be a slight fiddle. So let me do that. But in the end, I'm going to reduce this to one command. So everything I do here, I might have to collapse into one command so I can iterate that one command. It's going to look messy, so we'll build it slowly. First of all, let's generate the vectors from A to B, B to C, D, C to D, D to E, E to A by creating the same list as I've just got, but cycled round. Let's call it C points for cycled points. And I would like I'm using the curly braces for a list, by the way. I'm going to grab the last n-1 elements. I know I've got 5, so I want the last 4, but I'm going to try and keep this general. So I'm going to use the last command, and it says the last elements in a list, so it's the last of the points list. But I want, well, I know I want 4, but I'm going to do the length of PTS -1, so that if I made that length like 6 points, it would do me a list of 5. And that's going to create the last 5 points. It's just going to drop the first one. I think that's right. And then I want to put on the end of that list the first point. So I'm going to use the element command. I'm sure there are other ways to do this, by the way. In fact, I know there are other ways to do it, but I'm going to do it this way because I think it's easy to explain these commands and they're useful commands. So to grab one element from a list, I could grab name the list, which is PTS and element 1. And I think that command will always generate a new list which is cycled around. It feels a bit clunky, and there is a problem when I hit enter on this. I can see a double brace going on. It has made the 5 points. I can't tell from the screen which order they're in, but I can see them here, and I can see that the second one is become the first one. But there's a double brace there, which means it's got like a list of lists, and that's because my first element in that new list was itself a list. Maybe I could have defined it better, but I'm just going to flatten that list, which is GeoGebra's way of saying just make it one list, please. And That is what I want. So I've got points and then the cycled points, and that means I can get the vectors, let's call it vects, by running through those two lists and joining one point to the next. So I can use the zip command, which runs through lists. I want the unit vector of the vector from some dummy points P and Q, but basically I'll just say take P from the original list and Q from this cycled list, and I think that'll create some vectors now. Weirdly, it's put them over at the origin. They're all unit vectors, they're all the same length, they are going in the right direction. I don't need to see them. I could, for visual reasons, like put them back onto those points as they move. Let's sort that out later. I'm just going to hide that. Those are the vectors. I will need to be able to build this in one command, but already we've had to do some faffing with list commands to get those vectors. Hold that thought. Now let's do the iteration. I want to take point A and move it towards point B, and then I want to do that in such a way that these points get updated. I'm going to leave point A and B actually where they are. I'm just going to get a new set of points that have been moved slightly. When I do this, I find it much easier to do an example step first, so I get used to how the iteration command works. And you've seen some, well, you might have seen some other videos on my channel where I talk about the iteration commands. It takes a bit of getting used to because of handling the lists. So if this makes not a lot of sense, go and watch some of my earlier videos about using the iteration command and handling the lists. Let's see if we can do it though. Let's not do the full command straight away. Let's do the first step, which is going to involve zipping through that list of PTS. I want to use the CPTS list as well, but I need to define that probably in one command. So the way I built it, I'm going to sort of copy in eventually. Let's do one step at a time though. First of all, it's going to zip through, and I'm going to translate each point from the previous list towards its target using its vectors. Again, that vector command is going to have to go into this command eventually, but let's use the ones we built first of all for the first step. So translate an object. Let's call it I'm going to use X, capital X. Using lowercase x, bad idea because it feels like that's part of this graphing package. So it's a dummy variable though. Hold that thought there. X is the point I'm going to move. I'm going to translate it by a vector v. V is not defined anywhere else, so that doesn't matter. I just need to tell it which point X to get, well, which list to get point X from and which list to get the vectors from. So the X is going to come from PTS and V is going to come from the vects. Now, the catch is here, I think that's right, is that the vects had a lot of work to define it. And if I'm going to do this in one command using one original list, because in the end vects just depends on the original list PTS, I'm going to have to replace that definition vects with the sort of two commands I've already done. But let's get this working first. Create sliders for X and V. What have I missed? Oh, I need to tell it to use X from PTS and V from vects. And I probably also want a step control like I had in the previous thing, so I can control how far it goes. Let's build a step slider now. We're going to probably want it to be small, but let's let it go reasonably large so we can check what's happening. I can adjust those values later on. So that doesn't do anything yet. Let's make it translate it by step times vector V. And now that does adjust. Again, it's almost not big enough to see, but you can see this tiny new point is arriving. Okay, that's the next step, and it has generated a new list, which is kind of enough to then iterate. An iteration command needs to have one starting set of things, which it uses to create a new set of similar starting things, and then it can iterate it. The catch is that vects is defined in terms of the original list. I need it to be defined in terms of the new list every time, so I want this to go into one command. That's going to be okay. It's going to look a mess though, because I need to replace vects with the command I had here, and that command builds from CPTS. So let's do it one step at a time. I'm going to grab the vects command, which uses CPTS. I'm going to have to replace that, but copy that, and in L1, let's put it there. Just check that still works. By the way, the reason I used X earlier on here, because I didn't want to use P again, because P and Q I knew were going to be used there. Reusing the variables inside this thing is going to cause problems. I think that still works. So now I've sort of dodged the vex definition, but I still need the CPTS thing. So let's grab the CPTS definition, copy all of that. Only depends on PTS, and replace CPTS with that. I'm just kind of trusting that my original versions worked, so I'm not even checking what's going on here. It does look like that's still working. And now L1 is defined in some horrible looking long command It's gone off the screen there, which only references PTS. Everything else in there is a dummy variable. And that's what I need to iterate over. So let's select all of that, copy it, and try the iteration. I'm also going to leave a slider for how many iterations to do. Let's call it, let's make it an integer and I'm going to let it go high, but I don't want it to go all the way up to 1,000 yet. Let's just, go up in ones, and we'll set it to be 10. So as soon, or something small, it doesn't really matter. As soon as we try this, we should see 21 steps. There's going to be a bug, almost certainly. Let's try it and make it happen. And the point is, I copied that command, that test command, which I'm going to hide. I don't want that one. That was my trial, but I wanted to copy that, do it all in one parameter, PTS, and now let's do an iteration version of it. So iteration list, because I want every step along the way as well. I'm going to paste in the expression I just had, but here's the catch. I can't use PTS. I need to use a dummy variable again. This is dead confusing, isn't it? Let's call it capital L, standing for a list of points. I'm going to replace all the instances of PTS with capital L. So instead of using PTS every time, it uses the iteration L, which is going to start being as PTS. So that's replaced all the PTS with L. I wish I hadn't chosen an acronym for a traumatic syndrome. Never mind. The variable I wanted to iterate over is that L, and I need that L to have a starting value of my PTS. This is the bit I get confused about every time. This iteration command needs a list of starting points, so I'm going to put braces around it. It's a list of a list. I know. I think that's because you can have more than one variable it iterates over. Let's just not go there today. I need those braces, and I need it to go up n times. And that, I haven't pressed return yet, but it's already trying to do that. And if you get it wrong at this stage, things go wrong here. I'm going to press return. I think it's done it. This feels like an element of faith. All right, there it is. There's the curve of pursuit. And you can see I don't really need 1,000 iterations before they just get into the middle there. That's because my step size is big. If I reduce the step size, you can see you take a smaller step each time. And I'm already pleased these things are balancing out again. So let's make the step really small and crank up the number of iterations, and we can still get into the middle. Look at that. And the magic is going to come is if I move the original starting point. The curves move with it. Now, that is way more useful as seeing what happens than the other version where if you change the starting points, you're going to have to run the thing again. Now, I don't dislike that. It's a nice organic flavor, simple, just update, go along this line. This is a pain to get the iteration command to work, but that payoff is worth it. Now I can change the original starting points. They could even be over there, and I can see the curve of pursuit. I also want it to animate it though, and that would involve just changing the steps we're going through this list. So if I animate that, there's the same animation. The thing missing here, we haven't got the vectors on there. That might need a little bit of work, but there's a curve of pursuit, and I could even change it as we go. I probably want this to just increase. Unlike the T variable in the other one was a completely dummy thing just to using update it, whereas this one is controlling the number of steps in the animation. But you can change it even on the fly. And there's the power of using a sort of iteration building version over a scripting version. Let's do a tiny bit of tidying up on this and then just get an animation out of it. A couple of things I want to tidy up then. I want to be able to make this a regular shape. Let's do that quickly first. I'm just going to make a polygon which is regular. The polygon command can do all sorts of things, but in particular you could make 2 points. I'm going to do those 2 points and then tell it a number of vertices, in this case 5 for a pentagon. It hasn't made points for me, that's annoying. There's a command called vertices, a vertex of a polygon. I mean, it feels like I'm doing this backwards. Okay, now it's made the points of that. There might be a better way to do this, but let's just make a reset button like we did before. To pentagon, let's call it a regular pentagon. And this time, by the way, when you click the button thing, you get this, you can type the script in. Quite often I don't know what I want to type, so if you just press OK, I've now got a button that doesn't do anything. You have to right click on it, go to properties, go to scripting, and then look, there's an on click thing for a button. Other things don't have that, they just have an update. For sliders, actually, there's another box here for on drag end. When you finish dragging a slider, it might run a script. These are useful variants, because if you can't find your script, it's probably because you're on the wrong tab up here. So when I click this button, I want it to set the value of A to be, let's just work through the list of points I made down there. H, I, J, what? They're in a strange order. H, A, E, F, E, F is next. Let's do A to F, and so on and so forth. B to G. Why are they that order? It's weird. C to H, D to I, and E to J. Well, then I was finding that hard. I think that'll do what I want. Let's just check. And zoom in so they're appropriate. And now it does make. Oh, look at that pattern! I'm already liking that. In theory, I could make a button that resets it to a different thing, and I could add. I think because of the way of build out, I could add another point to my original list, and everything could still translate. You could do 6 points or 4 points without changing it. I'm not going to worry too much today. I don't really want to see these points. In fact, I don't really want to see that polygon. So let's just hide that. And the original polygon, maybe I don't want either. Or maybe I do. That's just the polygon joining the 5 points that we started with. Okay, good. That's a useful reset. So even if I drag D around, I can just dump it back there. By doing this with the grid on, let's turn that off. I don't really want that. It's going to look prettier. Goes quite quick, so maybe I can make the step size smaller. Incidentally, rounding it to 2 decimal places is also unhelpful when I want a tiny step size. So let's change the rounding in this to be 5 so I can see how small that's getting. It needs to be small. What I could do is crank this up to 1000 and then reduce the step size until we haven't filled the screen. I'm using Shift and the arrow keys to change this a tiny amount. It changes it a different amount with like a modifier with Control and Shift. Control does a big one, Shift does a tiny one. That looks like we've got a small step size, and the 1000 gets us all the way into the middle. That was just kind of doing it by eye. I would like these points to be smaller. That's the list of points, so let's just make them smaller. There we go. You are running into trouble. Like, there's a lot of points in here, so you can potentially crash GeoGebra with this iteration command if you let the count go too high, but it's not doing too complicated a thing. I mean, it's quite complicated when I built it, but it still seems to work quite nicely. So I'd also like to get a vector on the end, a little arrow showing where it's going. That's less obvious to me straight away. Before I do anything complicated, let me just save this file. Okay, to get the vectors on the end, like we had before, the little arrows, I need to get that last point, which I think is easy enough. It's the last element in the list, M1. By the way, I think it called it M1 because it thinks it's a matrix because it's a list of lists, but the last one is going to be the last 5 points. And what I did before will work on that particularly if I flatten that so it's not a list of one list, it's just a list of points. The vect command, if I grab that and change that to M2, but I need to update the seed points command to work on M2, so let's do that as well. Change that to M2. This is a bit of a pain. The other problem is that when it makes unit vectors, it seems to place them at the origin. Let's just let this refer to L3 instead. And I think these are the vectors I want. They're at the origin. So let's put them at a point P plus that unit vector. So P plus, no, let's do a vector from P to P plus that unit vector. Slightly awkward. There they are. They're at the right place. They're too big though. Let's make them smaller. It's because I shrank everything down to a pentagon with unit edge, so that unit vector is now too big. Let's just do like a fifth the size in there. That was somewhat arbitrary, but that is the sort of vector arrows, and we could have a little tick box to hide and show those. It would be nice. Show arrows, let's call them arrows, and it's just that L2 list, and that should hide and show them. Good, that's an arrowy upgrade, which I like. In terms of actually making the animation as an output, I haven't really talked about this in some of the other TMiP Animation Generation Collaboration videos, and it's kind of by hook or by crook, capture the thing you've made interactive in GeoGebra or something and get it into a video. And the easiest way to do that is probably just screen capture the file you've made. And there are lots of ways of doing that. You can export in GeoGebra as an animated GIF. I'm not going to cover that today. I'll mention that you have to choose a slider to cause the animation, and you have to say how long between the frames and do it as a loop. It can be a bit painful and take a long time. It does work and is in kind of a clean way of doing it. It makes you think hard about how an animation works. But for the sake of having full interactivity, I'm just going to screen capture this as one way of doing it. Now, I often use a screen capture in OBS, Open Broadcasting Studio, Open Broadcasting Software. I don't actually know which one the S is for. I'm using that at the moment to capture my screen for the video, so actually that's quite a hard demo. It's a good way of capturing a screen or doing all sorts of broadcasting or streaming stuff. But built into Windows, and I'm sure it's built into Apple products as well, is a screen capture still thing, which also on Windows 11 and since then includes a video capturing. So Windows Shift S, if I do that, probably my screen has gone dark. You can't really see on my screen capture what's happened, but it gives you an option to draw a box around the screen and grab that as an image. Very, very useful. At the top is an option to change it to grab a video, and you can choose to capture the desktop audio or your microphone audio as well. Quick shortcut built into modern Windows to screen capture it. And so what I've done in the GeoGebra file, I've just made a couple of buttons to do some controls, and if I intend to just screen capture, I can't drag a box, this region here, then I can make an MP4 file just using Windows built-in screen capture. Let's try and do that, and I'll finish with these animations. I might have even put it at the start of the video, who knows, see how well it turns out. So the buttons I've put in are to reset N, so wherever N is I can reset it, and I also put a button in to start the animation. I should show you the scripting, shouldn't I? Inside the scripting here is start animation, tell it the slider, tell it to do true. You could have a tick box to make it go false, and this one just sets N to go back to 1. So you can use buttons super flexibly. You don't have to have just one line of scripting in them. You can have multiple detailed full constructions on a button press, but these are just useful controls so that if I reset this, I'm going to screen capture just my pentagon, and then I can show moving it around as well. So I'm going to press Windows Shift S, I'm going to choose the camera, I'm going to draw a little box around the region I want to capture, and I'm going to click start. Now I have no idea what turned up on your screen then. I've got a little countdown. It's now live. I'm going to click anim, and it's doing the thing. Maybe I want the arrows on. There we go. And when the thing runs out, I could drag one. And because of the way I've built this, we can see the curves of pursuit changing as we go, and then I could reset it and animate those. In practice, I find the most pleasing results are when you've got a regular pentagon going on. So let's just do that one more time. In fact, let's get the arrows back. Stop. Show the arrows. Go. And when you're screen capturing this, like, you can faff around with it and then just crop to the bit of the animation that worked. That's good enough, I think. Okay, that was me building the curves of pursuit in a couple of ways. I hope it's instructive in how to build stuff in GeoGebra, and we made some fun patterns as well. See you next time.